Just a century ago, our understanding of the cosmos was remarkably limited. Astronomers once believed that everything, all stars, all creation, existed solely within the Milky Way. The idea of other galaxies, other realms beyond our own, was almost unimaginable. Then, in 1928, everything changed. Astronomer Edwin Hubble, through meticulous observation, discovered something extraordinary. The universe was not static. Galaxies were racing away from each other. Space itself was expanding. An unseen force was stretching the very fabric of the cosmos. That revelation redefined our place in the universe forever. Decades later, in 1997, the Hubble Space Telescope deepened that legacy. It revealed something even more astonishing: the expansion of the universe was speeding up. This acceleration was powered by a mysterious, invisible pressure now known as dark energy. A force we still barely understand, yet one that dominates the fate of everything that exists. This discovery led scientists to estimate the universe's age, 13.8 billion years. But that number may not be final. The mystery of M92. In the depths of the Milky Way lies a dense cluster of ancient stars called M92, one of the oldest objects ever found. But something doesn't add up. Some models suggest its age could match or even exceed that of the universe itself. How could anything be older than everything? Stars form after the Big Bang, not before it. And yet, M92 seems to defy this fundamental rule. Astronomers ran simulations across more than 20,000 artificial star populations to test the data. The results were shocking. The cluster appears to sit right at the edge of the universe's supposed birth. Could our cosmic calendar be wrong? Webb's challenge to time. Then came the James Webb Space Telescope, the most advanced eye ever pointed toward the cosmos. Webb peered deep into time, capturing galaxies that formed only 300 million years after the Big Bang. But they were too big, too evolved, too complex. By today's theories, such galaxies shouldn't exist so soon. It's as if the early universe matured faster, or perhaps existed far longer, than we think. Some scientists now propose a radical possibility. What if the universe is not 13.8 billion, but 26.7 billion years old? If true, that would rewrite everything we know about cosmic history, star evolution, and the rhythm of time itself. The Methuselah star and the Hubble tension. This isn't the only cosmic puzzle. There's another ancient object, the Methuselah star, officially called HD 140,283. Its estimated age? Around 14.5 billion years, apparently older than the universe itself. A paradox that challenges the very foundation of astrophysics. How can a star exist before everything else began? At the core of this confusion lies the Hubble constant, the measure of how fast the universe expands. Different methods give different answers. Measurements from the early universe show about 68 km per second per megaparsec, while nearby galaxies suggest 73 km per second. This conflict, called the Hubble tension, signals that something vital may be missing in our cosmic model. Could dark energy, once thought to be constant, actually be changing over time? If so, the entire rate of expansion might shift, altering our perception of the universe's age and fate. Beyond the beginning, maybe the Big Bang wasn't the ultimate beginning. Some physicists now revisit an ancient idea, the cyclic universe. In this vision, the cosmos doesn't have a single birth or death. It expands, collapses, and is reborn endlessly, a cosmic heartbeat of creation and destruction. Could the mature galaxies Webb observes be echoes from a previous cosmic cycle? Another possibility involves primordial black holes, immense structures formed in the universe's first moments. They could have acted as seeds, drawing in matter and jump-starting galaxy formation much earlier than expected. But if that's true, what else? The multiverse hypothesis of all the theories born from the cosmic frontier, none is more daring, or more humbling, than the idea of the multiverse. It suggests that our universe, everything we see, everything we know, might be just one of countless others. Each universe could have its own laws of physics, its own flow of time, even its own version of reality. In some, gravity might be stronger. In others, stars might never form at all. And in a few, just like ours, life might rise to ask the same question: why are we here? Imagine reality as an infinite ocean, and our universe as a single ripple upon its surface. Every ripple expands, collides, and interacts with others. Perhaps these collisions leave subtle marks, echoes, distortions, faint imprints of neighboring worlds bleeding into ours. When the James Webb Space Telescope peers into the deepest voids of space, it might be seeing more than ancient galaxies. It could be witnessing the interference pattern of universes overlapping, a cosmic mirage where boundaries blur. Some scientists call this concept the bubble universe theory, the idea that during the early inflationary phase after the Big Bang, countless bubbles of spacetime expanded separately. Each bubble became a universe of its own. If two bubbles ever collided, the energy released could leave a scar, a cold spot, a strange signature, something Webb or future observatories might one day detect. If that's true, then we are not merely citizens of one universe. We are participants in a vast multiversal symphony, where each cosmos plays its own melody in an endless cosmic orchestra. The quantum veil. But to truly understand the birth of universes, we must descend, not outward, but inward, into the quantum realm, where reality becomes uncertain and time begins to blur. At this scale, smaller than atoms and even particles, the universe is not a collection of solid objects. It's a restless sea of probabilities. Here, space and time ripple like liquid light. Energy flickers in and out of existence. Every particle can be in many places at once, until it is observed. And in those first fractions of a second after the Big Bang, these quantum fluctuations may have sculpted the very structure of the cosmos, seeding galaxies, shaping stars, and defining the cosmic web that stretches across eternity. Quantum physics also tells us something even more astonishing: time itself may not be a straight arrow. In the warped geometry around black holes, time slows and stretches. But in the earliest instant of creation, the quantum dawn, time may not have flowed at all. It may have flickered, paused, even reversed, as if reality itself was searching for a stable form. Some researchers propose that time could be an emergent property, something that crystallized only after the universe cooled and expanded. If that's true, then the age of the universe may be less of a countdown and more of a story still being written. A new cosmic perspective. Every image sent back by the James Webb Space Telescope is a window into that story. Each one stretches our understanding a little further, and at the same time, reveals just how much we don't yet know. Webb doesn't just look at stars. It looks through time itself, seeing light that began its journey billions of years ago, light that carries the memory of creation. When we look at those faint red smudges on Webb's deep field images, we are not looking at distant galaxies. We are looking at the past, still glowing, still speaking. And the message is clear. The universe may be far older, far grander, and far stranger than we ever dared to imagine. Perhaps 13.8 billion years is just one chapter. Perhaps there were universes before ours, and there will be others after. Maybe the cosmos is eternal, endlessly cycling through births and deaths, expansions and collapses, a grand pulse that never stops. What if the Big Bang wasn't the beginning, but merely the latest heartbeat of eternity? What if the galaxies Webb observes are echoes from a universe long gone, their light spilling into ours from a time before time itself? The storyteller among the stars in this light, the James Webb Space Telescope becomes more than an instrument. It is a cosmic storyteller, whispering tales of creation across 13 billion years of darkness. It gathers fragments of light, the language of the universe, and translates them into human understanding. It reminds us that science is not just about data and equations. It is about wonder. It is about curiosity. It is about asking questions so vast that they reshape how we see ourselves. Every revelation Webb brings pushes humanity a step closer to the ultimate truth, and yet, paradoxically, every answer opens 1,000 new mysteries. It's as if reality itself invites us to dream bigger, to keep reaching, to keep questioning. So what if the universe isn't 13.8 billion years old? What if it's 26.7 billion, or even timeless? What if our existence is only one flicker in an infinite sea of creation? One thing is certain. The James Webb Space Telescope has given humanity something priceless, the courage to confront the unknown. To gaze into the abyss and call it beautiful. To accept that mystery is not the end of knowledge, but the beginning of it.